Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to everyone. Our lecture today, we will cover chapter 2 of PST 431, which is polymerization reaction. Now, let's look at the first slide. Okay, for the introduction, traditionally, polymerization reactions have been classified into two main groups proposed by characters, which are condensation and addition polymerization. So in this chapter, we will discuss about the method to synthesis of the polymer, which is a process used to convert monomer molecules into a polymer. So we call it as a polymerization. And the two most important groups are by step growth and addition. So for condensation, it is a process to produce polymer contain fewer atoms as the monomer in its repeating units due to the formation of byproducts during the polymerization process. Condensation polymerization will produce byproduct, for example, H2O in this equation to produce nylon. And for addition polymerization, it is a process to produce polymer contain same atoms as the monomer in its repeating units. So by the addition polymerization, they have three steps, which is initiation, propagation, and termination. So for a step growth polymerization, it used for monomers with functional groups such as OH, COOH, COCl, and etc. And is normally but not always a succession of condensation reaction. And consequently, the majority of polymers formed in this way, it differs slightly from the original monomers because a small molecule is eliminated in the reaction. For example, the reaction between ethylene glycol and terephthalic acid to produce polyester. While for the addition polymerization for olefinic monomers are chain reaction, which convert the monomers into polymer by stimulating the opening of the double bond with a free radical or by using the ionic initiator. So the product then has the same chemical composition as the starting material. For example, if you want to produce the acrylonitrile, produces polyacrylonitrile without the elimination of a small molecules. And also the length of the molecule chain, which will depend on the reaction condition, it can be obtained from measurement of the molar masses. But arise an ambiguity towards some condensation polymers and addition polymers. As an example, we can see in this example to produce the polymer by condensation and the addition polymers. Therefore, polymerization reactions are now commonly classified according to the polymerization mechanism, which are by step growth polymerization and chain growth polymerization. So the step growth polymerization, it is a process to build up polymer chains in a stepwise fashion by a random union of monomer molecules to form dimers, trimers, and higher species throughout the monomer matrix. While for the chain growth polymerization, it is a process to build up polymer chain from the very beginning of the reaction that required the presence of an initiating monomer molecules to link to the end of a growing chain. So what I can say about the difference between the step and chain is in step growth, any two molecular species can react, but in chain polymerization, the monomer can react only with the reactive species. So the presence of the reactive species in the chain polymerization is crucial, and the reaction mixture contains a range of different size species in step growth compared to the chain, whereby the chain growth polymerization, it contains only high polymer, monomer, and reactive species. And high molecular weight is achieved only at very high conversion in step growth polymerization compared to the chain growth polymerization, which is high molecular weight. is obtained initially and continuously during the process of polymerization. Now we look at the details of the step growth and chain growth general characteristic. For step growth, we does not need the initiator to incorporate in step growth, while the chain growth polymerization it required the initiator, which is this initiator will initiated by a highly reactive chemical compound. Okay, for step growth, only at very high conversion are products with a high molar mass produced, while in chain growth, the chain growth quickly, generally within a matter of seconds, to a higher molar mass. And in step growth, all molecules are equally reactive and involved in the polymerization process. In particular, there are no chain-carrying reactive species with limited stability. In chain growth, only a small portion of the molecule in the process are actively involved in the polymerization process, and the growing radical, the remaining molecules are unreactive. That is, they can only react with radicals but not with themselves. So at the end of the topic, students should be able to define general terms in topic, list and explain all characteristics in step growth, write the chemical structure, calculate the dP, list and explain all consideration to achieve high molecular weight as well as to control it, and briefly explain the gelation in step growth polymerization. Now we look at the animation step growth polymerization by Martin Intivel. Okay, the figure one show the schematically illustrate the step growth phenomena for a system of 12 monomer molecules. Okay, as in a figure 1a, the monomer molecule it contains functional group A and B. So functional group from A will react with the functional group B to form the AB linkage. And in B, half of the conversion, which is 50% conversion, the monomer molecules are consumed, right? And in C, we can say that about 75% conversion of the monomer molecules are consumed. And in D, all which is 100% conversion of the monomer molecules reacted, but each polymer or the oligomer molecule still has reactive end groups. Hence, the polymerization reaction will continue in stepwise fashion. Okay. We look at the characteristic of step growth polymerization. Any two molecular species in the mixture can react, which the reaction with the suitable functional end groups often proceed without the need for catalyst. Molecules growth stepwise occur throughout matrix by reaction between monomer, oligomer, and the polymer. The activation energy or off rate is about the same for each reaction mechanism step. The average molecular weight increases steadily with reaction time. Long reaction time are usually necessary to produce high molecular weight, which is at the end of the reaction, and the monomer molecule disappear very quickly, and the polymerization rate decreases steadily as functional group consume. So this is some characteristic for step growth. The polymer prepared by step growth polymerization, we have the ethylene oxide structure here, ethylene glycol, formaldehyde, acetaldehyde, ethylene glycol, and terephthalic acids. Caprolactam, 11 aminoandicanoic acid, and so on. Okay, now we look at the type of the reaction in step growth polymerization. We have type 1 and type 2 in step growth polymerization. So what is type 1 and type 2? Okay, we look at the type 1 first. Type 1 is one type of polyfunctional molecule. and the molecule have two or more functional groups. So A and B is a functional group, means that in type 1 we call it as a polyfunctional, and in type 1 more than two in one molecule. There is more than two monomer or more than two functional group, actually more than two functional group in one molecule. So this is considered as one molecule. Okay, so in this molecule we have A functional group and B functional group. So for type 2 is two types of a polyfunctional molecule, which is we have AA and BB, so also called as a bifunctional. So each functional molecule have one type of functional group. So each molecule have the same type of functional group, which AA, and the other functional polyfunctional molecule have BB. Okay, so hope you can see the difference between type 1 and type 2. Now we look at the example of type 1, which is polycondensation of hydroxy carboxylic acid. For example, in type 1, as I mentioned earlier, more than two functional group in one molecule. So this is a molecule. So we have OH functional group and also COOH functional group. And for example of the type 2 polycondensation of diol with dicarboxylic acids. So in diol, we can see that they have OH functional group and also OH functional group, means that it has a same functional group in a monomer. Maksud dia ada satu jenis functional group dalam satu monomer. Okay. Untuk yang ni pun dia ada satu jenis, iaitu OH, COOH. Okay. COOH. Right. Example of polycondensation of hydroxy carboxylic acid. One monomer, which is hydroxy carboxylic acid. So hydroxy carboxylic acid contain OH and COOH, which is more than two functional group in one molecule. So it has OH and COOH. So it means that dia ada dua functional group dalam satu molekul hydroxy carboxylic acid. And when undergo the polymerization process, polylactic acid PLA is made from the reaction between the same monomer containing an OH and COOH group. It is described as a condensation reaction as water is eliminated as the ester link is formed. Okay, the example is illustrated here. Hydroxy carboxylic acid with the same repeating units will undergo the polymerization process, and the functional group in this monomer will react between the molecular species to produce the polymer at the end of the reaction, which is high polymer molecular weight is achieved at the end of the reaction, and the monomer concentration decrease rapidly with early stage of the reaction. Type 2, for example, in the polycondensation of polyamide, it formed from the reaction between the two monomer containing two NH2 and two COOH groups. So as I mentioned earlier, in type 2, we have two types of functional group. For example, we have monomer molecules in compound A and molecules in compound B. So in compound A, they have same functional group. In compound B, they have two functional group with the same functional group. Okay, two functional group with the same types of functional group. So we can see that in 1,6-diaminohexanes, they have NH2 and NH2 here. For hexene 1,4 dioxide, COOH here and COOH.